Until now, we have only looked at the analysis of the whole model. However, we can also analyze specific parts of the project, so-called local models or subsystems. A subsystem can be created manually with the command subsystem view and by selecting the desired elements. The software will then generate a new view which contains parameters, identifying it as a subsystem. However, generally, subsystems are used to study 2D slab models related to each level. For this reason, there is a specific command, subsystem views per level, which allows you to select all the desired levels and, most importantly, to automatically allow for load transfer between each level, or more specifically, each subsystem. If we work with subsystems, we then are focusing on parts of the global model, or main system, which do not necessarily have external boundary conditions. Of course, we could add them manually, but we would then need to calibrate them correctly and filter them out of the main system. Since the boundary conditions of a subsystem usually come from the neighboring objects, the software can automatically detect those and convert them into supports. For this, the structural properties of each object includes a section regarding subsystem support. For each type of support stiffness, you can choose whether the object should be converted and whether the support should be rigid or elastic. In the case of elastic support, the software will automatically determine the stiffness based on the geometry, material, and local boundary conditions. If needed, you can still factorize this value to account for the global situation. Another common specificity of subsystems is the need to study a more detailed loading configuration. For slabs, it is mostly common to generate the chessboard loading pattern. With the help of the standard Revit tool model line, and by setting these lines with the style SOFiSTiK load divisor, you can draw the pattern that you wish to have. In SOFiSTiK's Utilities menu, go in the Load command and choose the function Load Pattern. Then, select both the slab load and the division lines. SOFiSTiK will then create new load cases based on the original one, allowing for various loading combinations, hence ensuring a more precise and accurate design. Both original and new loads stay in the system and simply get assigned a new parameter. You can then use the Revit filters to sort which load should be in which system. Now, if we study each level as a subsystem, it is important to ensure that loads coming from the levels above are well accounted for, like in the 3D model. This is what we call a load takedown. We can obviously create loads manually, but fortunately, SOFiSTiK can perform a load takedown between levels. The software will then take the reaction forces from an upper level and generate corresponding forces on the active level subsystem. Indeed, the software has in memory the position of the levels in relation to each other and can also account for walls and columns which are not included in the 2D slab subsystem. This load takedown can be done by creating the loads in the view so that you can then adjust or modify them. For this, we use the command transfer loads. The software will then indicate which loads can be created and the various load cases concerned. However, a more recommended method is to have this load transfer done automatically by the software when performing the linear analysis of the subsystem. Although the calculation menu looks the same as for the main system, some new options will be proposed in the tab General, one relating to the automatic creation of boundary conditions, the other with regards to the load transfer. Be very careful not to mix both manual and automatic load transfer, otherwise you will account for these loads twice.